So now that we understand what caching is, let's understand how to populate a cache, right? So cache typically sits between your API and your database. There is no hard and fast rule per se, but cache typically sits there logically. Physically it may be anywhere, but logically that's where it sits. Now when you have an API server and a database and a cache, the flow goes like this. User makes a call to API server. API server checks the cache. If it has the data, it sends back. If not, your API server talks to database, gets the data, pushes it into the cache, then returns to the user. Right? This is one most popular way of populating the cache. It's called lazy population. So we are not eagerly putting data into the cache. Instead, we are letting a request come, it having a cache miss, which means I could not find it in the cache. Then we are going to database and populating the cache. This is lazy population. That's the idea behind lazy population, and it is most common way of doing it, because here why it's called lazy, because you are not proactively pushing data into the cache. You are only, so your cache will only contain the data for which any request came in. I will say, oh, but if I get request for everything, will my cache contain all the data? Not really, because whenever you set something into the cache, you would always set an expiry to it. Let's say 5 minutes, 10 minutes, 50 minutes, depending on the use case that you have. But what this expiry ensures is when that time comes in. So if let's say you set a particular key K with expiration of 5 minutes. Once that 5 minutes ends, that key is automatically deleted from the cache, which means that you would not have entry in the cache that is never hit again. It would eventually be automatically deleted from the cache, reducing the memory footprint of your cache. Right? This is really important, because if you set something into the cache with no expiry at all, that key, that data would be lying there forever. And you don't want that. That is a classic example of memory leak, right? Because your RAM of your machine is bounded, which means that because it is bounded, if you fill that up, you would not be able to accommodate more data into it. So that is where it is always better that whenever you set something into the cache, irrespective of how you're populating it, you always set some expiry to it, right? Okay, a practical example of lazy population, caching the blogs. So let's say you're building a blogging application. In order to fetch a blog detail, what you need is you would be joining 3 or 4 tables: blogs tables, author table, tags table, and whatnot. So for a given blog ID, when I'm creating this blog object, this is an expensive process, right? You have to join 4 or 5 tables, which is expensive thing. You do disk.io, read this and send it back to the user, right? But when you're compiling this JSON, what if you store the JSON that you just created in the cache as a blog detail? So blog ID in detail, you store the actual JSON thing. Now what happens? The subsequent request that comes in goes to the cache, finds the exact same JSON object that you have to return, and you just return it to the user. There is no need of expensive DB computation at all. So caching blog is a really common place, is a really good place where you do lazy population. And you store data into the cache, which is pre-computed. Now your request comes in, goes to cache, gets it back, sends it back to the user. Dead simple. Right? Now, contrary to this lazy population, and it is the most popular way to populate a cache, other way to do it is eager population. Now, eager population is where you are proactively trying to push into the cache. Now, there are 2 ways to do eager population. First is when you are getting a write for your database or for your system, you are not just writing to your database. You are making 2 writes, one to the database, one to the cache. You are proactively pushing it into the cache. Now, where would you need it? Let's take a very practical example. Let's say you're building a cricket score website, something like Cricinfo or CricBuzz. When cricket match is happening live, there are thousands of users reading that cricket commentary. When they're reading that cricket commentary, what would happen is you need to sustain a high amount of read load. So what you do, you put a cache in between and you let this cache serve all the reads. Right? Now what happens is when the score gets updated, when commentator updates the score, you typically think of updating it in the database. Let's say you only update it in MySQL, right? That's your private database and you update it. And now what you're doing is you're relying on this eviction to happen or expiration to happen in the cache. Then only it would have a cache miss, go to the database, fetch the updated score and send it to the cache. Right? This is where the problem is, because now it would happen is the score got updated, but you are waiting for the key to expire, then only you would update the score. But a better experience would be that when you are writing to the database, you proactively write to cache as well, so that the people who are watching the cricket commentary, or rather reading the cricket commentary, gets the updated score right away. You are not waiting for key to expire. You are proactively updating the cache. So next read request comes in, your cache already has the data because your API server is actually writing at both places at the same time. This is eager population. One way of doing it, where your API server itself is proactively writing to database as well as cache. Right? Second way is where you proactively push the data into the cache. It may not be that your API server itself is writing at two places, but it's more about that, hey, if a tweet is made by a very popular person, let me proactively push the data into the cache. It's not that your API server is writing things in one shot at two places, but more about, let's say, an asynchronous way of doing it. Let's say you know that a popular person tweeted about something. Now that tweet is definitely going to go viral, so you're proactively putting it into the cache. Not everything, but something that you need, you're proactively pushing it into the cache. You saw a trend of a video. On one more example, let me give you one more example to understand it better. Let's say you are YouTube and you have a trending page, right? Now when you have a trending page, you know, or rather, let's say you have a recommendation thing. So on YouTube, when you open, you see a bunch of recommended videos, correct? The recommended videos that you see, the video which is being thrown at people in the recommendation feed are very likely to be accessed because you're showing it as the first thing on YouTube, right? So people will click on it. So now when you know that you are pushing this thing to everyone in recommendation feed of a lot of people, you can it is not a recently published video. It is an old video, let's say 2-year-old video. But right now your recommendation engine is pushing it into other people's feed. So now what you do is you proactively cache the video metadata in your cache. This way what happens is you would not have cache misses and all. You know that this is something that I am pushing and everyone would be reading it. You proactively push it to the cache. It's not something that is done immediately, which is why in this approach where you are talking about live score, your writes are happening at two places, in your DB and your cache. In the second one, you know that this is going to be accessed very frequently in the coming time. You are proactively pushing it. It may be something which was published a long time back, but then you're still caching it because now you know that because you would be putting this video in recommendation feed of a lot of users, it is very likely to be accessed. That's why you are proactively pushing data into the cache. So these are two ways to do eager population. So we saw lazy population, the most popular way. Eager population, we saw two approaches where your API server writes at two places, and another one where you are proactively pushing data into the cache because you know that this is something that would be going to be accessed frequently in the near time. Right? Okay. Now that was all about populating the cache. Now let's talk about how to scale a cache. Cache is very similar to a normal database. So the scaling technique of a cache is very similar to scaling technique of a database. So we start with what? Vertical scaling. That hey, if I want to cache more data, let me put more RAM, more disk, more CPU into my cache. So you vertically scale a database. Similar to how we scale normal databases, persistent database, same thing goes over here. Second is read replicas. Exactly how read replicas work in databases, same thing or cache, no difference. That when your cache is read heavy, where you're making a lot of read requests, one node is not enough to do it, you have a master replica setup, right? And API server knows the address of both. So API server, depending on the request, can send it to the replica or can send it to master, right? The data is replicated across multiple nodes. And third, when this goes beyond that you have huge amount of data to cache, that's where you go for distributed cache or you go for sharding, where what we do is instead of having one cache, we have multiple caches, each handling mutually exclusive subset of data, right? And the way your sharded databases work, exactly the same way your sharded cache work. Your API server knows the address of all three. It has some logic through which it is routing the request to the corresponding shard, maybe hash based routing, maybe range based routing. and it would just populate the data or access the data from that particular shard. And each shard may in turn have replicas, right? Similar to how your database works. And so whatever we looked into talking about scaling a database holds true for scaling a cache, because caches and databases are not very different. Caches are just faster databases, if I may put it that way, right? And that's all. That's all what I wanted to cover about populating and scaling a cache. So I hope you found it interesting. Hope you found it amusing. I'll see you in the next one. Thanks a lot.